Yes, today we are going to see a new chapter on kinematics. The new topic that we are going to see is uh, uh, we are going to see about cam mechanism. Till now, we are seeing about how the linkages are designed in such a way that to form a constrained mechanism, and we have seen about how the inversion is achieved and how different mechanisms are achieved, and we are also learned about mechanical advantage and transmission angle in the mechanism. So all this we have studied, and now we are going into the shifting into another topic. It is on cam mechanism. So what is cam? How cam is making a usefulness in the engineering application. So I'm going to share your screen. Hope you are able to see my screen. Can you see my screen?
Yes, sir.
Yeah. So cam,
Sir.
as you see in the screen, it can transmit the desired motion from one surface to other. Hello? One surface to other by direct contact. Okay, transfer from one to other. So we call the surface from where the motion is transmitted is as a cam, and motion to which it is transmitted, we call it as a follower. Can you see a two type of motion over here? You can see two type of motion. You can see in this here. So this blue color one is a cam, and this is a follower. So this is used in many applications because this kind of transfer of motion is possible with less space to occupy. Whereas if you want to achieve this kind of actuation at particular time of interval, it will take more space to achieve this kind of mechanism. But here, with less space, we are able to achieve the transfer of mechanism. So you can see what is that is achieved in this mechanism. Can you see in this both cam mechanism? What is achieved here is it is able to actuate this. Yeah. Vallikanan, what do you want to say?
Reciprocating motion.
Yeah, it is transmitting a reciprocating motion. It is not transmitting a simply reciprocating motion. It is not transmitting a simple constraint motion, but it is transmitting a programmed reciprocating motion. That is, at this particular theta, from this point to this point only, it is giving a lift. All other point, it is being stable. Even though cam is rotating, it is not giving any output motion to the follower. So it is designed, the cam is designed such that it can make the actuation mechanism only at that particular time interval. That is, and the time la mattumna adu vandu it should give a upward motion. Na the time எப்ப வரும் எவ்வளவு RPM ல சுத்தும் எந்த டைம்ல லிஃப்ட் கொடுக்கணும்ங்கறத கேத்த மாதிரி it is giving a input. Okay, so it is designed such a way that it will give the lift only during that particular theta, and also the fashion in which it is giving a uplift and downlift, that is the desired kinematic motion. Kinematic motion is measured in what? How kinematic motion is measured? What are the parameters that we measure the kinematic motion? Velocity, acceleration, and displacement. That is how we measure. So this fashion in which the kinematic motion is transmitted to the follower is also based on the design of the cam. And the cam oda slope எப்படி design பண்றீங்கன்னு அதை பொறுத்து தான் வந்து அதோட velocity acceleration of the follower எப்படி மூவ் பண்ணி அந்த மெக்கானிசத்தை கம்ப்ளீட் பண்ண போகுது ஆர் ஆக்சுவேஷன் பண்ண போகுதுங்கிறத இருக்கு. ஸோ நம்ம இந்த சாப்டர்ல என்ன பண்ண போறோம், வாட் வி ஆர் கோயிங் டு see in this chapter is we are going to design the cam to achieve the follower mechanism with the steady state of output that we desire to achieve. That is, this is the velocity flow diagram or the acceleration flow diagram in which we need to achieve. For example, okay, that is how we are going to design. So in the curvature of the cam is very important here. So we are going to design the curvature of the cam to suit the application and to suit the output follower that we are going to use. So you see in both the mechanism, two kinds of follower are used. So this follower is called a knife edge follower, and this follower is called a circular follower. Okay, so can you see any places this kind of mechanism is applied?
Camshaft, sir.
Yeah, crankshaft is
camshaft, sir.
Camshaft, yeah, correct. When different engines are that is also one kind of cam, but it is like when different engines are operating at a different power stroke, and this camshaft integrates all the power and it gives output to the flywheel. So camshaft is one similar to cam, but this is there are many types of cams. Okay, we are going to focus on the radial cams in this chapter.
Sir,
So
the drilling machines, the one they use in a constructions, can that also use cam, sir?
Yeah, whenever you want eccentric kind of output, they use cam. If you don't want to have a streamlined output, and if you want to have an eccentric kind of output, or if you want to actuate a mechanism at particular time interval, we use. You see a clear application here in this two diagrams. You see, where is the cam here? Where is the cam here in this two mechanism? Where is the cam here? The first diagram is showing a internal combustion engine, and you see the cam is rotated here. The green color one is called the cam. The green color one is a cam. The green color one is the cam. Can you see? Can you see where it is? So I'm giving a tick over here. I'm going to show an arrow here and to show where the cam is. Okay, so this is where the cam is located. Okay, these two cam. You can see the engine. What is the main function of the engine? Is it has to allow the fuel and air mixture at particular time, and then the exhaust gas should go out of the outlet valve at particular time. So we are designing the cam in such a time uh, interval based on the theta rotation, and also we are making the slope to achieve the particular displacement pattern and the acceleration pattern to achieve this open and closing properly. So there are different motion in which you achieve this movement. So as I told, the acceleration, velocity, and displacement decide the way in which it open, the rate at which it open and close. Everything is based on the acceleration velocity pattern in which it is going to excite. This cam is going to excite the valve, and we have to analyze the motion that is the displacement pattern also before you go into apply for the real time. Okay, we have to analyze the displacement pattern very peculiarly because we have to give a smooth operation. It should not give us it should not give a sudden acceleration, sudden deceleration, and or else there should be proper constrained closing mechanism. So we have to design properly. So this is the thing. You can see the same mechanism is shown in the different way here. You can see the 360-degree rotation of the cam. It is giving a lift during the places where the profile is going out of the base circle. This is the base circle. Profile is going out little bit. So during the place where this profile is going out little bit, it is giving a lift to actuate this mechanism. To actuate this mechanism, you can see it is giving a lift to actuate this mechanism. So that is the what happening. Okay. So you can see here this is giving a lift and actuate this mechanism. So actuation is happening. So that is what. I hope you understand the use of the cam and how the cam is used here. And I hope you are clear with cam and its use very well now. So you are ready to go into the deeper into the subject to know about the design of the cam. Okay. Hope you understand this concept.
Yes, sir.
Yeah. So now
Yes, sir.
we will go on to learn about the types of the cams and follower and how far we can go in to design of the cam. And in this chapter, as you are going to design the cam, you should what? You should draw. You should draw. So I hope you are having your drafters with you. You take it out, drafters with you, and drawing sheet. If you have A3 sheet, you can use. Otherwise, A4 sheets. You have plenty of A4 sheets for my class from today onwards. And I'll give you time in between. In the time, you can take your A4 sheet and your drawing instruments, and you can start using it one by one to learn about the design pattern of the cams. Okay. So this chapter is completely drawing based chapter. So you should always have your pencils, instruments with you. Okay. Hope you have any difficulty in this. You all have your drawing sheets and instruments with you, no?
Yes, sir.
Sanjit is only answering.
Yes, sir.
Okay. Okay. I hope yesterday's assignment many have submitted very good, and still, but there are some blank sheets. I saw one or two people, but majority submitted, and so whenever assignment is submitted, it's for your good, because anyway, very shortly we'll be having the regular classes and final exam. Anyway, you have to draw and practice, so it will be useful for you. That's why I give you in between assignments. It will help you. You will feel when you are going for the final exam. Final exam anyway, it is going to be fully conventional, so it will be very useful. So then and there, I'm giving a small assignments only, so I give time also. You can solve it. Don't take it as a burden. Surely it will be useful for you. So we'll go for the next thing. So cam system, follower system, is used to make a specific motion to actuate some mechanism to happen. Actuate specific motion you want to achieve. So normally the profile has to be in a different shape so that the follower will exhibit a desired shape. Okay. So the cam is attached to normally the cam is attached to the rotating shaft. So the cam is attached to the rotating shaft in order. So as the cam rotates, the profile or shape of the cam that causes that. So profile of the shape of the cam, that is what main thing. The profile or shape of the cam, you see, underline. Profile or the shape of the cam is the main player. That is what playing a vital part here. Profile and shape of the cam that causes the follower to move in a particular way. It makes the follower to move in a particular way. So the movement of follower is then transmitted to the another mechanism and another part. This is based on the situation we can do. But here the profile of the cam is what we have to be very particular about. We have to achieve the good profile of the cam. Okay, so this profile of the cam is, for that only we are going to work out. We are going to work out and learn things to achieve, because many things are there. Just we cannot design a cam and to get a, I want to lift my follower to this level, so I am just making a profile like that, so that it is not. Why it is not? I want to lift my follower to 5 centimeter. So I just make a cam such that just give a lift to my cam and draw. It's not just lifting a cam is not, it's not going to be correct. Why it is not going to be correct? If I want to have a cam, the cam will have a base circle. You know it is going to have a base circle. If I want to give a lift, what I should give? If you want to give a lift to the follower, what I can do?
To elevate that cam. For
That's
like
all very
5
simple.
centimeters.
Elevate. So simply elevate the cam. I want to achieve 5 centimeter lift. Just I give a 5 centimeter. This one, it will push it up. Is it enough? Do you think it is enough?
No,
height
sir.
of the profile, that height of that irregular part should be 5 centimeters. So that it push it up.
Yeah. This 5 centimeter I have put. No, is it enough to give a lift?
No, sir.
Is enough to
5
give a lift?
centimeters should be.
5 centimeters. I'm giving from here to here. I'm giving 5 centimeter lift, so it will give a lift. Definitely, you are getting the actuation, but the way in which it is activated, the slope is very important. How it is? It is accelerated. Very good. Accelerated. Acceleration. How it is accelerated? The way in which it is accelerated is very important. The way motion that we are achieving, that is also very important, because that is also play a part in your mechanism which is you are trying to actuate. Another part of mechanism you are trying to actuate. So this acceleration and motion that it is producing to make the lift is playing a vital part. So the design, even the slope of the design and everything is very important, because the theta angle, if this is the axle, this is the theta in which it is giving a lift, correct? This angle only it is giving a lift. So it can also give the lift in a wider angle, correct? Am I right? It can give a lift in this angle from, for example, it is giving a lift this 90 degree. I can give a lift even from here, can make it bigger, or I can make the lift from 30 degree. From here also I can give a lift, correct, like this. Am I right? Do you think all are same?
No, sir.
No, that is what we have to be. We have to get, we are concerned about. How we are going to design the cam. Lift we are going to achieve, but how the lift is going to be achieved, what is the shape exactly you have to design the cam to achieve that is the real challenge. So there are different types of cam. These are called wedge cams. Wedge cams. These are called wedge cams. These are called wedge cams. Okay. So wedge cams. Wedge cams, you can see these are all called wedge cams. So this follower is constrained. So when this is moves, it can give a upward motion. This is also one kind of wedge cam. So here the follower used is called what? What is the follower used called?
Roller.
This is a roller follower.
Roller.
Yeah, roller. It's a roller follower. It's a roller follower. Here we are using a roller follower. Roller follower, and this is a knife edge follower. This is knife edge follower, and this is also a knife edge follower. These are all different kind. You see the slope in which this transmit is different, and this slope is different. Okay, so based on the design criteria for the mechanism to achieve, we design it. So these are all called wedge cams, but we are not going to design any wedge cams in this chapter. We are going to we are just for the knowledge level we should know about the wedge cam, but we are going to more concentrate on the radial type of cams. So this type of cams are called radial cams. Why this is called radial cam? Because these cams has got a base circle. These cams have got a base circle. So this is called the base circle. Base circle. Why it is called the base circle? Because the cam profile or the lift of the mechanism that we want to achieve is designed away from the base circle. So base circle, when the follower is moving on the base circle, the follower is not making any movement at all. Even though the shaft is rotating and making the cam to rotate, it is not giving any movement to the follower, correct? During when it is in the base circle, but when it is above the base circle, your design profile come into play. So your design profile come into play. So here they have designed a profile like this. You can see a different profile they have designed, and this is a profile. From here it is deviating from the base circle, and this is a profile they have designed to make the lift action. Here also, up to this it is going in the base circle, and after that they are giving a lift. This is the lift they have designed to make the forward action happen. Okay, so that is what this kind of cams are called radial cam. This it has got a radius for a base circle, and the profile that gives a lift is projecting. It will have higher value than the base circle, so that it can give a lift to the follower. This kind of cams are called radial cams. Radial cams. Okay, so radial cams are very important. And cylindrical type of cams. These are all cylindrical type of cams. See here, in the cylinder there is a groove that is cut here. So whenever this is rotating, this groove is making, trying to make this kind of motion to the follower. So since it is moving to the groove is going inward, it will go inward. When the groove is going outside, it will go outside. So it will go, so movement will be, the follower movement will be like this, move outside, inside, outside, inside. That's how it goes. So these are the kind of follower that is used. What is the type of cam here I'm showing in the diagram? I'm showing 3 diagrams. What is the type of cam it is used here?
Sir, knife edge, the first one.
Radial cam.
Radial cam. So these all are cam. I'm asking about cam. So all these are what?
Radial cam.
Radial cam, yeah. All these are called radial cams. So follower is different here, but the follower is different for each case. The first case, the follower is called knife edge follower. So you got a knife, it is has got a sharp knife like a pinpoint. So the contact is established only in that single point. It is like this. Okay, it is like this. It is like this is sharp point. So when it is rotating, the contact is established only in a single point. For example, when it is rotating in a circular thing, the contact is established only in a single point. So this is the roller follower. So roller follower, as you know, the contact is different actually. It is rolling. It is like rolling, no? It is like rolling above this. The contact is a little different. Correct. It is not a point. It is not a single point, but little more surface is coming into contact when the cam is rotating, trying to move the follower. Okay, and also because if we say if you put a normal line between the center of the cam and the follower, and the tangent exactly perpendicular, that is a tangent that is common to the cam and the follower, will be maintained at every point of time. So that is okay. And also there is another one major difference you see in the knife edge follower and the roller follower. Can you anyone say the major difference between these two kind of follower?
The separation gap between the follower and the knife.
Very good, very good. Excellent, excellent, Ronak. It's an excellent answer. Actually, here it is directly, follower is directly in contact with the cam. But here, follower is not directly in contact. There is a gap exist. There is a gap exist between the follower and the cam. So
Sir,
when
can
you
we say that the follower actually has 3 links and the knife edge follower has only 2 links? Can we say it
yeah,
like
three
that,
links,
sir?
3 links. Yeah, it has got 3 links. Actually, it has got 3 links. You are right. We have got a lower pair over here, but in this chapter, we are concerned about only 2 things. We don't want the third thing. We want only 2 things. What are the 2 things? One is the cam, another one is the follower.
Follower.
So other follower is attached to many mechanism. That is okay. That is all we are. And even the cam is attached to the shaft, which is driving the mechanism. All these things are there. But we are much concerned about only 2 things. One is what? The roller and the follower. So when we design this, the gap that is existing between this is created by another element, because the nature of contact in which the follower is making with the cam is a roller type. So it is not similar to the knife edge type. So when you design it, we should be careful, because we have to consider this gap. This gap is nothing but what? What is the distance of this gap that we are having? What is the distance of this gap? How will you know the distance of the gap?
That the prime circle.
Radius.
What?
Radius of the circle,
Radius
sir.
of the
Radius
roller,
of the
Yeah,
follower.
it is a radius of the
roller.
roller. It is a radius of the roller. It is a radius of the roller. Here it is direct contact, no? Okay. So this is the first class for for cam. For you, is it second class for you?
Second class, the last class I gave the
Last
introduction.
class I took.
Second class.
Answer to draw.
Okay. So I thought this is the first time I am taking to you like that I am taking. Okay. So you have already seen to all these, no? We should go for the next thing, I think. So the flat face follower is how we are. Here the pattern is like tangentially it is going. Okay. So we'll move forward, because already we have seen this for you. So I have shown all this knife edge follower to you. So I need not tell you again. Roller follower and flat face follower. So already you have drawn this nomenclature and all. Okay. So I know everything about the nomenclature. So no problem. What is a pressure angle? Anyone say what is pressure angle? Shivani? Valikanan? Valikanan, can you say what is pressure angle in the cam?
Sir, the normal to the pitch curve and the direction of the follower motion, sir.
Oh, very
Angle
good.
between.
Very good, very good. So pressure angle is also very important when you consider the design of the cam. But so you should know that also. So we'll go for the next part. That is the motion in which it is giving the follower. What is the type of motion it is giving to the follower? That is more important. So now I think you are thorough with this terminology. Actually, these are all construction lines. Only this cam, this is a cam. This is a cam. This is a cam. It is a this is a base circle, and this is a cam profile that we achieve to achieve the follower mechanism. This is what it is given here. So since you have drawn the diagram, you should be knowing in depth the position of all the things, terminologies of this cam mechanism. So there are different types of cam motions, and last class I'm just brushing out the cam mechanisms to you, and today we are going to draw the motion. Okay, first kind of motion that the follower gives to the cam gives to the follower is simple harmonic motion. Simple harmonic motion. The simple harmonic motion will be like this. This is the simple harmonic motion that we see in any mechanism. Okay, this is a simple harmonic motion. So you see, what is this distance from here to here? What is this distance from here to here? Can you interpret this diagram?
Diameters.
Wait, I will say you. So this is called displacement diagram. Displacement diagram means what? What is the purpose of displacement diagram? What is the purpose of drawing a displacement diagram?
Know the position of a body.
Hmm?
To know the position of a body at a certain time, at a certain period of time.
Yes, you are right. This is the rotation of the cam. When cam is rotating, that is, for example, this is if you take this is 60 degree, you take 60 degree. This entire span is 60 degree. If you take for 10 degree, it should give this much lift. 10 degree. For 20 degree, it should give this much lift. For 30 degree, it should give this much lift. For 40 degree, it should give this much lift. So 50 degree. That is what we should achieve. The pattern in which it goes should be in the way of simple harmonic motion. So this is the pattern we should achieve, is simple harmonic motion that we have to achieve. So over 10 degree ஆகும்போது எவ்வளோ வந்து ஃபாலோவரை லிஃப்ட் பண்ண போறோம் அப்படிங்கிறது தான் முக்கியம். That's why we call this as a displacement diagram. We call this as displacement diagram. We call this as a displacement diagram. Okay, for every 10 degree, how much lift we want to give. So அப்படின்னா இது என்ன இருக்கும்? இந்த full length எவ்வளவு இருக்கும்? என்ன இருக்கும்பா? 6 to 6 dash will be what? 6 to 6 dash will be
the follower displacement.
Maximum displacement.
Yes, Nitin, correct. Nitin and Ronak has told the correct answer. The maximum displacement that we are going to give the follower. There is a maximum. You can say maximum lift. Maximum lift. It is going to give the follower. So maximum lift that is giving to the follower. This is the maximum lift. Okay. Or sometimes we say this as a stroke. So different book they use different terminology, not a problem. So this is the lift that we have to go. So we are designing the pattern. So totally how much degree is there totally? How much degree we have to design this displacement diagram? எவ்வளோ டிகிரிக்கு நம்ம பண்ணணும், நம்ம டிசைட் பண்ணணும். How much degree we have to design this displacement diagram?
So for every 180 degree turn is enough, sir. Like, are you saying in that way, sir? Like, for how many rotations?
Total. What is the total degrees the cam is rotating?
360, sir. For 360.
360, correct. It is
360, sir. But then 180 will be enough to determine the whole. I mean, the entire displacement, sir. Am I right?
No, yeah.
No.
Most of the cases, but in not all cases. It is 360 degree is correct. Sometimes you may be giving lift for the entire 360 degree, but slope may be varying. Correct. But most of our cases we design for the one within 180 degree only we are designing. That's why you are able to say that. But it is need not be 180 degree. You can even decide a lift for entire 360 degree, but the slope keep on varying based on the acceleration pattern we require to achieve. Correct. So normally what we do is we will have the base circle will be here. If you want to make a lift for 60 degree, if here from here to here it is 60 degree, from here to here it will make a lift. Correct. So if the here this is 60, so here actually 60 degree it is lifting. It is lifting for 60 degree. Then again there will be a dwell for some period. Again you have to draw a similar diagram like this to descent. Understand? So from that is what it happens. So this is just a lift. It doesn't finish up to the lift. See, the lift is happening for 360 degree. After that, if there is a flat surface above, there will be a dwell for some period. Then then you will have a fall. Again it has to fall. Your fall, for fall what degree it should take? For make the follower to fall, what degree it should take? How much degree it should take?
Above 60 degrees.
Yeah, it can be above 60 degree, 30 below
Above
60
60
degree,
degree.
anything. There is no rule like that. Even you can have 90 degree for a fall and 60 degree for the rise. It is based on the output you want. There is no guideline that rise is 60 degree, fall also you should be 60 degree. Not like that. Don't think like that. We can have different rise and different fall. It is not. It is not constrained. It is not defined that you should have same rise and same fall. So this is the basic diagram. We are going to draw a simple harmonic motion, and in this class. So this is a simple harmonic motion that we are going to draw, and this is a velocity and acceleration pattern we are achieving. The velocity and acceleration pattern we are achieving, and this is the displacement diagram, sample displacement diagram. This diagram is drawn to check the movement of the follower at different theta degree. Okay, so inga vandu 80 degree and 60 degree almost approximately. Theta naught means outward stroke, theta r means return stroke. So this period is called what? It is staying at the same place for some time. This is called dwell period. This is rise, this is down, this is the stroke, complete stroke. Even this stroke is common for everywhere. So this is what we have to draw. So I'm going to give you a problem to draw a simple harmonic motion, and you can draw step by step as I say, so that it will be easy for you rather than sitting alone and drawing on your own. Okay, so you can take your A4 sheet and instrument and come. And meanwhile, I will take the attendance. So you know when your name is coming, so that you can plan and take your instrument box. I hope all are having A4 sheet and instruments with you.
Yes, sir.
At least you should have a bigger sec square. If you can manage, if you have a bigger sec square. Drafters will do if you have a big table, and you can use the drafters. If you are unable to use the drafter, take the scale in the drafter alone and manage now. You need a protractor. And for drawing the profile and all you require for this, you can manage with this curvature. You have to draw in freehand only. This one you have to draw freehand only. This one, these things you are going to draw freehand only. The other construction you are going to draw by using geometry. Okay, so that is it. You can Same way, when the cam instead of the follower being here, it is kept, the follower is kept here. Follower is kept here, then it is called this distance. What happened? And this distance is called the offset. So this is inline, this is offset. So whether this offset is there or not, you have to see. What is the condition here? What is the condition here? Huh?
Inlines.
Inline, because there is no mention for it. So if there is no mention for it, it is inline. We have to see is there or not. Have to see whether there is offset. So we have found the type of motion, we have follower, we have found the type of motion, and we have found that there is no offset in this problem. And then we have to think about the angles. Type of follower we saw, motion and the angle. So outstroke, you have outstroke and instroke. So whether outstroke and instroke are in different motion or same motion, you should know. Outstroke, instroke are making different motion or same motion. This thing you should know. Here it is making different motion or same motion. Here also simple harmonic motion. Here also same.
Same, sir.
So sometimes
sir.
this also will be different. Okay, so you should be very careful. So question, you should take your time to verify all these first. Whenever you get a question paper, we are going to attempt a problem in a cam mechanism, and you have to see this carefully. You should see the type of follower and the motion it is going to exhibit, the offset, about the offset, and then the nature of outstroke and instroke, whether both are same motion or different motion. So these things you should carefully see before going for the drawing a problem. So for attempting this problem, first what we have to do is we have to draw a diagram called displacement diagram. Why displacement diagram is drawn? Displacement diagram is drawn to find out the displacement of the follower at each degree rotation of the cam. Each degree rotation. How much degree rotation is it totally?
360, sir.
Totally 360 degree rotation is there. Correct. So when you expand it, when you expand it, so we have to predict the displacement for all the 360 degree. So displacement has to be predicted for the entire span of 360 degree. Correct? Am I right? So displacement is not happening at some time of time during the cam operation. Displacement is not at all happening in this during the cam operation at some point of time. What are the places? Displacement is not at all happening at some places. Where are the places? Where are the places?
0 degrees, sir.
Huh?
40 to 300, 360.
No, you can here. Okay. Yeah, displacement. Yeah, well, yeah. Here, this displacement is not happening, and remaining also displacement is not happening. The dwell period there is no displacement. Remaining also period also you are not having displacement. So in these places, what is happening? In these places, what is happening? In this
Displacement
place,
equal to 0.
in this place, displacement is 0. So we need not concentrate more on drawing a displacement diagram for these places. Correct or not? So you're not going to have each degree, you are not going to have an increment in the or a push in the follower. So this is not much important. This place is especially not important at all. Correct. If you draw or not, it is going to be in the baseline. So otherwise we can say it as the follower is touching the base circle during this period. Correct. So let me draw the displacement diagram first. First, let us draw the displacement diagram. So we should I am going to draw the displacement diagram. So displacement diagram we are going to draw. So for that, what is the line we have to draw is 360. We have to draw a 360 degree line. We have to put a 360 degree line. So I am putting a 360 degree line. 360 degree. And the height should be, what should be the height? Height should be, height of the displacement should be what?
6 centimeters, sir.
It is given in the question. What is the height?
The stroke or the lift of the followers.
Yeah, 6 centimeter. So you put, we can put 6 centimeter here. 6 centimeter. So 360 degree we can draw, but what is more important now? 120 degree. First is we can say theta outward stroke is 120. Then what is happening? Dwell is happening. So del is 60 degree. Then return is happening. Return theta r we can put. Return stroke is 120 degree. Then again we should say this is a dwell only. It is also a kind of dwell, but it is below, that's all. Remaining means you can, what is the degree? It is remaining how many degree? 120, 60.
60, sir.
Remaining 60 degree will be there. This is also a dwell. So we need not draw this. This is not required to draw. Which one? I told you, as I told you, not required to draw this. This is not required to draw. So we focus on this. So 120, 60, 120, how much it is coming?
300.
Huh?
300.
300, yeah. 300, yeah, 300. So 300 degree we have to draw. 60 degree again, anyway you are going to have dwell only. So 300 degree. So if you put 300 degree, you take your A4 sheet and you can draw. 300 means 30 centimeter you can draw. 30 centimeter you can draw here, this one. Or else you can make it as a 50 centimeter. 50 centimeters, 2 millimeter will be, sorry, 1 centimeter. If you take 1 centimeter is 1 millimeter is equal to 1 degree, then you have to take 30 degree, 30 centimeter, 300, no? Yeah, 30 centimeter line. 30 centimeter line. If you have, you can, 30 centimeter line is not possible, no? In A4 size sheet. When you're drawing in A3 sheet, huh?
Sir, A4 not possible, sir.
A3 la neenga normally variving exam ku that appa neenga easy ah varanjalam. A3 is what we are going to use for the examination. But since you are in home, you are having A4, so we can take even smaller dimension. So another
15 centimeter.
1 millimeter is equal to 2 degree எடுத்துக்கலாம். ஆமா, 15 centimeter. 1 millimeter is equal to 2 degree. So இது வந்து 15 centimeter எடுத்துக்கலாம். 15 centimeter எடுத்துக்கலாம். 15 centimeter ஒரு லைன் 15 centimeter போடுங்க. இந்த height எவ்வளவு இருக்கணும்?
6 centimeter.
என்னப்பா
6 sir.
6
6 centimeter.
6 சென்டிமீட்டர் போடுங்க. ஹைட்டுக்கு ஸ்கேல் பண்ணக்கூடாது எப்பவுமே. Don't scale this height because that is a deciding parameter, no? This is just for our reference to know for each degree how much it is moving up. Why man, it's making a lot of problem. So நீங்க வரைஞ்சிருப்பீங்க நீங்க you can draw man, you can don't wait for me. For me it will take more time than you because this digital pad so
Sir,
you
sir, we should draw that 6 centimeter also, or we should not draw, sir.
draw 6 centimeter yak. What man?
Vertical line 6 centimeter we should draw, sir.
Yes, you draw
Okay, sir.
6 centimeter line, yeah. This is 6 centimeter, no? 6 centimeter, yeah, 6. So இது மாதிரி பண்ணிருங்க. அதுக்கப்புறம் நீங்க டிவைட் பண்ணும் இத. Can divide it now. You know what is the division you should make?
30 degrees, sir.
First is 120 degree. First outstroke is 120 degree. 120 degree means is equal to outstroke is 120 degree. According to our scale, 120 degree is how
60
many?
millimeter.
60 millimeter, yeah. 60 mm. So exactly locate 60 mm and put this line. Locate the 60 mm and put this line. Okay. Then the outward stroke is what? Outward, that dwell period, no? Dwell period is 60. 60 means 30 mm. 60 degree, next is 60 degree. So 30 mm. 30 mm, you put the another line. So anyway, the last stroke is going to be 30. Last 60 mm, no? If you want, I will just for your reference, you put it, but not required. Okay, this is also 30. But this is not required. I am putting. If you put in the millimeter, it is 60 mm, 30 mm, and 60 mm. This one 60 mm, 30 mm, 60 mm. Again, this is 30 mm. Okay. Have you finished up to this?
Yes, sir.
So I will ask someone to show. You are going to show. Okay. Are you ready? Sriya. Sriya. You can show till what you have finished.
So I'm drawing it, but my video is not set up. So
Okay. Suryan. 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 Are you there?
Yes, sir.
Show your diagram.
I'm doing it, sir.
You finished drawing it. Show your diagram, man.
Sir, my webcam, I haven't given it permission, sir. I have to figure it out.
You are how long you will figure it out, man?
Sir, hello.
Sanjit. Sanjit.
Yes, sir. Yes, sir.
Show your diagram, displacement diagram.
1 second, sir.
So I am now open to everyone. You can show, anyone can show. Sanjit is showing, and it's open to everyone also. Anyone can show your displacement diagram till now. Bhavin. Sriram. Sendur.
So I don't have web camera also.
Sanjit. Sanjit, what? Roshan. Murugappa is going to show the displacement diagram. Sanjit. Very good. What when you are drawing by freehand? You're using freehand or you're using drawn by scale?
Scale only, sir.
Okay, okay. Okay. Okay, good. Hey, all others are drawing or not, man?
Yes, sir.
Yes, sir. It's a drawing, sir.
Okay, okay. So now you can start making a simple harmonic motion for this mechanism. So we know the degrees, and if you want, you can mention here for your reference, so that we can we will not the degree is from here to here. It is 120 degree. From here to here it is dwell period is 60 degree, and again from here to here it is 120 degree, and the last part is not required, but I have drawn it so that you should not forget this. If you draw it, it's not
Sir,
a
you
problem.
should, sir, if you can divide the lift by the outstroke, you can like plot the graph much more fluently, sir. Is that the way it's supposed to be done?
What do I don't understand?
So like if you divide 6 centimeters by 120 degrees,
Okay.
you'll get like what is 6 centimeter by 120 degrees?
6 centimeter 120 degree. Yeah, that's what you have
Yeah.
done. La. Yeah.
So you can plot it for like you can just we can't just draw it freehand, no sir, from 120
Freehand
degrees
is
to
not
0.
permitted. Yeah, you have to draw it accurately. Freehand is not
That's
permitted.
why I'm asking. Is that the way to do it, sir?
Yeah,
Like,
we have to divide it and properly do it. I'll show you one by one. So now I will rub this. This is, no, we have scaled it since we are using A4 sheet. Normally, you need not scale it. Normally, 360 degree means 360 millimeter you can take directly. Okay, this is total rotation is 360. You can take 360 degree 360 mm. But since you are using A4, we have taken 360 degree as 180 mm. Correct or not? So automatically 120 degree is 60 mm. So 120, this 60 is 15 mm. So that is what we have achieved. So now I'm going to draw a simple harmonic motion. So now what you have to do is you have to take your compass and you draw a semicircle. You know what is the center of this? You know what is the center of this? What is the center of this?
3 centimeter.
Yeah, it is 6, so it is 3 centimeters center. Now this as a center, you draw a circle. Draw a semicircle. Draw a semicircle. This semicircle you can draw using compass. If the diagram is very small, you can use pro circles. No, a lot of circle will be there. But here it is 6 centimeters, so we cannot use a pro circle. We have to use a compass. So this is a center, and you have drawn that circle. And this we are dividing into 6 equal parts now. How to divide this semicircle into 6 equal parts? One method is 180 divided by 6. You can use protractor and mark it and then put the line. Another method is, what is the circumference of a semicircle?
I into R.
Yeah.
IR, sir.
Yeah. So you divide the circumference into 6 and then cut it by arc. Divide the circumference into 6 and then cut arc. That is one method. Or else you can simply divide. You can take the compass. Then you can use any method for doing that. So 1, 2, 2, 3, 4, 5, 6. So we did it into 6 equal parts, and we are going to draw lines to meet this point. We name it as 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Now we divide this 120 into 6 equal parts. How many division you are making it? The same division you should make it here. In each theta naught and theta r. Here if you make 8, here also 8 division you can make. So you get the better displacement pattern. So you can have any number of division. 6, 8, 10, 12, anything you can have. Now I have made 6 division. Here also I am going to make 6 divisions. So you make 6 lines here. So 1, 2, 3, 4, 5, like that.
Sir,
Equal divisions. Don't follow my diagram, man. You do it correctly. Equal divisions. That is 20 degree. For every 20 degree, you should put a line. 20 degrees for us 10 mm. Correct. This length you divide into 6 equal parts. Okay. Similarly, this length you divide into 6 equal parts. One, 2, 3, 4, 5, 6 equal parts. Here also 6 equal parts, 6 equal parts. Okay. So like this. So what you do is you draw, yeah, if you finish this step, you draw a horizontal line from here. From each point, you draw horizontal lines. Even you can extend this here, not record well on here. So you should get this. Correct. Have you finished up to this? 6 equal parts, this one. So name it as so 1, 2 dash, 3 dash. Here 1 dash will be same point. 4 dash, 5 dash, 6 dash. Okay, like that. Sorry, you can do like this now. here 1 2 3 4 5 6. This numbering will be easy. You can do a numbering as you like, but I think this numbering will be better. 1 dash 2 dash 3 dash 4 dash. One of the division is missing here. 3 dash adjust. So it's difficult. Okay, have you finished up to this? Hope you have finished up to this.
Yes, sir.
Yes. So now you spot the point where 1 is intersecting with 1 dash, 2 and 2 dash, 3 and 3 dash, 4 and 4 dash, 4 4 dash, 5 5 dash, 6 6 dash. Similarly here also. Here also you put 6 5 4 3 2 1, no? 6 5 5 5 4 3 2 1. So now we can draw the profile. Okay, once you have drawn this, the profile of the profile, not this is a displacement diagram. After reaching this point, it's going to dwell. So we are going to continue this diagram with this. That is how we are going to achieve. Exactly. Should draw nicely. No overlap should be there.
Sir,
Only one single line should draw.
sir,
Tell me.
sir, after extending those 1, 2, 3 and all those points to the other side, how are we doing those other set of lines, sir?
Same way. This we have marked 6 5 4 3 2 1. So 6 coinciding with 6, we mark this point. This 5 coinciding with this 5 point. This one. 4 coinciding with 4 point. This is theta r, no? Return stroke.
So each point is 1 centimeter apart here.
Which one? Each point is this difference?
Yes, sir.
1 to 20 degree. This 6 to 5 is 20 degree. 6 division, no? 20 degree. Then in our scale it is 10 mm.
Okay.
One division is 20 degree. So in our scale it is 10 mm.
Okay.
Okay. So this is the profile we got. So using the profile, using the displacement pattern, we have to draw the profile. Using the displacement pattern we received, we have to draw the profile. I have finished drawing the displacement simple harmonic motion. Bhavin, you can show your displacement diagram. Here actually what we have taken is 2 millimeter, 1 millimeter is equal to 2 degree. That is what we have taken. No? If you are
Yes,
drawing
sir.
in a yes, 2 degree you have taken. Taking as 2 degree. 1 millimeter is equal to 2 degree. This is the scale we assumed.